go.
Okay. All right, so like we were saying, converging and diverging, we have two different types of images. Our real is where light is actually diverging from the image. Virtual, it just looks like it's coming from the image. It looks like it's diverging from the image, but it's really not. So in this case, I have my plane mirror again, light bouncing off the mirror, striking into my eye. The virtual image, if I follow those reflected rays and I trace them back, that's what your eye is doing for you. This image truly is not there. It looks like that light is coming from the flame in that candle, but it's really not. Question? Go ahead.
I don't understand it.
Huh?
Like, that mirror in the middle, is that just like the image that's appearing on the mirror?
Right, so here's your object. And my object is, I have a bunch of light rays that are coming from the object, hitting the mirror, going into my eye. But I see an image, right?
Right.
But does that mean that my candle is really on the opposite side of the mirror? And my light rays aren't striking the mirror and going through the mirror, are they?
No.
No. So the reason that I see this image is because these reflected rays are coming back. This is what your brain is telling you. Your brain is telling you that these images are coming back into where the image actually is. So it looks like those light rays are coming from behind the mirror, but they're really not.
Is that why they're like backwards?
Say again? Is that why? Jonathan, go ahead.
Yeah, like pictures, like when you look in the mirror, like stuff is.
Why you have like a right, left,
like
kind of
like in
discrepancy
Mean Girls
thing?
when she did her K, it was backwards.
Sure, yeah. Something to do with it too. Okay, so let's look at these two. I have object distance, which we have symbolized as DO. So object distance is just DO. And I see that that's the distance from the mirror to my object. So my object distance is just always going to be the distance from the mirror to the object. My image distance is going to be the distance from the mirror to the image. So I have object distance, I have image distance. So from mirror to object is object distance, mirror to image, image distance. Okay. Felicia, what's the law of reflection? You got this. Good. You got it.
I don't know.
Let's do the angles.
Oh yeah, isn't the angle of incidence equal to the angle of reflection?
Very good. Law of reflection states that the angle of incidence is going to be equal to the angle of reflection. So we still have to think about that in the back of our mind because that's still going to hold true. These are all of these things that we've seen on the previous slide. So my law of reflection was definitely here, where that angle of incidence had to have equaled that angle of reflection. So that's where that went into place. We saw our object distance. We saw our image distance. We see a virtual image. We're going to do several examples of these. So I'm going to do some examples for you on the board. We're also going to do examples in class on Monday. So we're going to do tons of these. So hopefully you'll be able to determine the differences between virtual and real while we're doing examples. Okay, last thing on this slide. Typically scientists are interested in two image features. Those features that we are very interested in are height and orientation. We can find both of those things by something that we call the magnification equation, or just magnification. And we know that that's going to be image height over object height. So we have HI, which would stand for the height of the image, over HO, which is just going to stand for the height of the object. So I know we did this last year. I think a lot of us called it hi-ho last year. So magnification, M is hi-ho, high over ho. Or plane mirror.
Like a ship.
Like what?
Like a ship.
Yeah. Okay, so for a plane mirror, the magnification for a plane mirror is always going to be 1. It will always be 1. And the reason that it will always be 1 is because the height image will always be equal to the height image, or the object height. So image height will always be equal to the object height for all plane mirrors. So your plane mirror will always have a magnification of 1. Now, I'll get more into what the plus and the minus is in just a minute when we start to talk about convex versus concave mirrors. Okay, so for plane mirror, image is always upright. If it were inverted, I would see that flame down below on the surface here, and the bottom of the candle would be up above. So I know my image is upright because it looks exactly the same. I see that my object distance is equal to my image distance. My object height is equal to my image height. So it means my magnification is 1. I know the image is a virtual. How do I know that? There are dashed lines that are emanating from these reflected rays. I know those dashed lines aren't real. They're not real at all. So because they're not real, I know that this image has to be virtual. I know light really isn't diverging from this image. It's not really coming from that image. Okay, so upright, virtual, unmagnified. What I mean by unmagnified, their heights are the same. I don't have something that's smaller or the image isn't larger than the object. Okay, let's talk about spherical mirrors. Of course, there's going to be 2 of them. We're going to have concave, we're going to have convex. Now, we know that convex mirrors are like what? How can we talk about a convex mirror? Like, what would it look like? What's its shape? What about concave? What would a concave be? Would it be like where it's kind of sunk in, or would it be where it's folded out more? In, right? So concave would be like, it's kind of all sucked in. It's like hunched in and hunched over. Convex would be like, we're more out. Nice round, yeah, like a nice little round, pregnant little belly, right?
She had a grip.
Yes.
She had a grip.
No. Okay, let's label some of these names. I think we saw some of this stuff last year, but we're still going to go through it all. Let's label it all again.
You get it to stop.